Hey everyone, and welcome. Today, we're jumping headfirst into the world of data security. We're going to pull back the curtain and look at how companies protect their and your most valuable information. This is all about the essential layers that keep our digital world safe, with a big focus on cryptography. Let's get right into it.
So let me ask you something. When you think about your data out there on the internet, what do you picture? Is it locked down in some high-tech digital vault? Or is it kind of just sitting in a cardboard box with private scribbled on it? The truth is, not all security is created equal, and that's exactly what we're going to break down today. Before we even talk about firewalls or encryption or any of the cool tech, we have to start with a much simpler question. Why are we even protecting this stuff in the first place? Because a truly great security plan isn't a product you buy off a shelf. Nope, it's a strategy. And that strategy always begins with understanding the risks. And this is where it gets real. Before anyone writes a single line of code, you have to ask, what's the worst that can happen? I mean, think about it. If a bank gets breached, yeah, there are huge fines. But what about the non-financial side? The loss of trust? That can literally sink a company. Knowing what you stand to lose is step number one. Okay, so you know why you need protection. Now, what exactly are you protecting? This is where data classification comes in, and it's the bedrock of any solid data loss prevention strategy. Honestly, the easiest way to think about it is like taking a giant digital rubber stamp to all your files and marking them public, internal use only, or top secret. So, how's it actually done? Well, there are frameworks for this, like ISO 27001, and they pretty much boil down to these 4 steps. First, you just figure out what you have. You can't protect what you don't know exists. Then you create your buckets, public, confidential, that kind of thing. For each bucket, you make rules, who gets to see it, who can touch it. And finally, you put those rules in place. And, this is key, you check on them regularly to make sure they still make sense. All right, so we've sorted all our digital documents into piles. We know which ones are super sensitive. Now what? Well, now we actually have to lock them up. And in our world, that lock has a name: encryption. This is how we take that important stuff and stick it inside a digital vault that nobody can crack open. And here's something absolutely critical to understand. Data exists in 2 states, and you have to protect it in both. You've got data in transit, that's stuff moving around, like an email flying across the internet. Think of that as an armored car. Then you have data at rest, which is just data sitting on a server or a hard drive. That's the vault. You need to secure the armored car and the vault. One without the other is a huge security hole. So what is encryption at its heart? It's beautifully simple, really. You take readable information, plain text, and you scramble it into unreadable gibberish called ciphertext. That's it. So even if a hacker manages to steal the file, all they have is a useless jumble of characters. Without the key to unscramble it, it's just digital noise. And that brings us to the most important part of this whole discussion. I'm serious. If encryption is the lock on your vault, then the keys are everything. Who holds them? Who can use them? How are they protected? Because if you have $1 billion lock, but you leave the key under the doormat, that lock is completely worthless. This is precisely why things like a key management service, or KMS, were invented. Instead of developers hiding keys in code or config files, which is a huge no-no, a KMS is like a dedicated, ultra-secure digital fortress just for your keys. Its only job is to create, manage, and protect the things that unlock your most valuable data. So when you start using a KMS, you'll hear a few terms thrown around. Let's quickly demystify them. Customer-managed keys just means they're your keys. You control them. Key policies are the rulebook. Who can do what with this key? Grants are like giving someone a temporary guest pass with very limited access. Encryption context is a fantastic extra check. It's like a secret password you have to know in addition to having the key. And key rotation is just good hygiene, automatically changing the locks every so often. Let's make this real. A policy might say something just like this. It's not just saying the finance app can use the key. It's saying the finance app can use the key only if it also presents that extra piece of info, that encryption context. If another app steals the key, it doesn't matter. It won't know the secret handshake, and the KMS will deny the request. It's an incredibly powerful way to lock things down. Okay, deep breath. We've covered a lot of ground. Risk, classification, encryption, and the all-important keys. So let's pull all these threads together now and look at what a complete, modern data protection strategy actually looks like in practice. And here it is. This is the playbook. First, you classify. Then, you encrypt everything sensitive, no matter if it's moving or sitting still. You use a central KMS so you always know where your keys are. You write super specific rules so people and apps only have the bare minimum access they need. And finally, you log and audit everything. You watch who's using your keys, when, and why. It's a cycle. Protect, enforce, and verify. So, look, if you take away only one thing from all of this, let it be this right here. You can buy the fanciest, most expensive encryption on the planet. But if your key management is weak, if your keys are lost, stolen, or misused, then all of that security just evaporates. It all comes down to controlling the keys. And I want to leave you with a final thought to chew on. Building all this is great for protecting your data against the threats we face today. But what about tomorrow? There are things on the horizon, like quantum computers, that could theoretically break the encryption we rely on. And that's why the real pros are already working on the next evolution, post-quantum cryptography. Because in security, the job is never, ever done.